mathematical matrices. So the given data, we put the given data like this: A matrix, NPRY, the -1 as we have given, and the p-value will be the array. Also, this is also the matrix, so this is its source, and y-not value. This is a boundary condition, so NP the array of that. So we put like this initial temperatures at each node. Then we give the int 1 second. We'll discuss why we give the int at 1 second. We'll discuss lastly. So then define the numbers of nodes. We have 4 nodes, y1, y2, y3, and y4. Then number of nodes are length of y0. That means, as we have discussed, there is 4 nodes. Okay. Then RK for made for a single step. We are going to define the functions of the step function. So RK for step as a function of y, h, a, and b, because as we have seen before, there is the functions here. Let me show you. There is RK for formulas here. K1, K2 considered as a function of h, a, b. This is the functions. So we are going to put this in the functions of step function. Yeah. So there is K1 h times a, h times into a times y plus b, h times ay plus 1 over 12 K1 plus b. This is the formulas in the given data. Then y new is the node vectors or the node temperature for our solution. The node for our case there is a temperature. So this is the iterative one. So we are going to find this node values. So we give the time stepping here, time points. We give the time points here. NumP is NumP, and 0 is the initial value, Tn plus h is the final value, and h is the rate or the gap. So why we need to take this one Tn plus h? Because we should include this Tn. We should include if we don't plus h here, the solution will exclude this Tn value. For example, if the equation is executing from 1 to 5, so we can't able to include 5, the end value. So to include the end value, we use this one. Then y solution is NP zeros, length of time status, and number of nodes. So y solution at 0 is y0, as we have already discussed. So for iteration here, for iteration in a range, starts from y. This is for y or the vectors for the temperatures. We can say the temperatures. This is 1 starting from 1 to length of time points. Then y solution is I is equals to iteration of y is equals to RK times step, RK for step function as a function of y solution, a -1 is function of h, a, and b. So I -1, why we put here I -1? Because we start from y0. I started from 1, so we take y0. Then, so this is all here, as you have seen here, is for the mathematical values, and the rest, the next is for the plotting value, the plot results. So for plotting, we use plot lab here, the plot function from the first head, from the header. So plotting the temperature evolution for each node. Plot figure, this is the size. We can choose as we like at x and y axis here. We can maximize and minimize the size of the output. For nodes in range, we use for nodes range, number of nodes. So we will this one is for partition this graph values. For example, the y and the x-axis values. So to partition to show the graphs, how we are going to partition each y and x-axis values within the range of the nodes in the range of time. Okay. Okay. Then plot time points. This is for the x-axis y solution. Y solution at any time stamps to node. That means there is a timestamp and node connections or relations on the graph. So we label that node, for example, for the y-axis, node +1, for example, node as node 1, node 2, node 3, and node 4. This is for the y-axis partitions. Then plot x label as time. This is to make time to express time on the x-axis and temperature and the wax in centigrade in this seconds. And plot temperature function at each node. And plot grid, we put a grid and legends. Legends are to explain what the colors are and what the graph is shown us. Okay, then this is all about the graph values. And also to show you the heat map of the temperature distribution. So we need to use this plot figure. Then figure size, you can also change this one. But I am show y solution anti aspect auto. This aspect auto means just we can minimize and maximize based on our devices. So then this is here is a C map. The C map is hot for our case. It is temperature, so we will use this C map for hot. Okay, this means color map. C map is also here. Y solution dot means the transpose of the solution of Y. If it is a raw matrix, we can transpose it to make it column matrix. Then this extent means how extent the values are. So the time is from 0 to the end, and the nodes are from 1 to number of nodes. And it will origin a lower means at 0, 0. All the lower values of the time in the nodes. Okay, then plot color. There is a color label, temperature to show the temperature. There is a color bar. So we can put the color bar like this. And X label time and Y label as node. And the title is temperature distribution over time. And plot Y tick, there is a tick on the numbering. There is a tick, so we use the ranging. There is a ranging for the ticks. Then for Y, we need from 1 to number of nodes +1. There is a ticks at each node. Then if not, I range from 1 to number of node +1. This is for ticking the graphs of the y-axis and also the x-axis. Okay, then plot show. Then finally we print the result here. Print final temperatures. Print final temperature at the equals to the end. We will see the end values, the output finally, and also those are showing the heat map of the temperature distribution and the graphs of the nodes, the node temperatures, and here we print the final temperature of at the end after some iterations the Python did. So for node in range, number of nodes, the nodes print f node. So we'll put node 1. Here is to make it node 1, which equals to this much temperature, node 2 this much temperature, node 3 this much temperature. So here is also 2F here. 2F here. This 2F is decimal place of the temperatures. How much will permit to show us the decimal place, the decimals. So, for example, if there is 12.123, if 3 decimal places will minimize to 2 decimal places. So this is also shown us as degree centigrade. Okay. Then output here, we have the final temperature values, node 1, node 2, node 3, node 4. Here is the temperatures. Okay, this is the final output values. So all are start from 20, that is initial boundary conditions. And here is node 1 is higher and node 4 is also moderate, and the node 3 and node 2 and node 3 are somehow less. So node 1 is higher because it is a heat source of 100 degrees centigrade, and node 4 is also moderately higher because it's a heat source of 50 degrees centigrade, and thus the rests are the conductions. Now they are getting these conductions from node 1 and node 4. So why node 3 is lower? Because node 3 is conducted with node 4, that is moderate temperature, and why node 3 is somehow higher? Because it is conducted with node 1. So thus our temperature rises with conduction. Okay, then why we are going to use this only 1 second? Because after 1 second, the values are almost the same. After that, is constant values. So it is the time of this is the value where the temperatures are
Time is up.
or start. There's no change in its time. See the values. Okay, then you can see this temperature profile, as you have seen, like this temperature profile. This is node 1. This is node 2. It's node 3, and it's node 4. So node 3 is blackly because it is a low temperature regions. And also, this is it. Thank you.
ኦኬ በሰዓት ስለጨረስክ 1 ደቂቃ ተጨማሪ ተጠቅመሃል። ስለዚህ ፈጠን ብዬ ጥያቄዎችን ጠይቃለሁ። ከዛ ለግሩፑ ምናልባት ጥያቄ ካሏቸው ያው ፈተና ራሱ ሊመጣ ይችላል፣ ይሄ አሁን እሱ ያቀረበው። ስለዚህ እናንተም በጥንቃቄ ያልገባችሁ ነገር ካለ እንድትጠይቁ ነው። የመጀመሪያው አት የሚለውን ይሄ አርኬ ፎር ፎርሙላን ዲፋይን ስታደርግ አት የሚለውን ማልቲፕሊኬሽን ተጠቅመሃልና how is it different from other sort of multiplications? That's my first question. My second question is ግልጽ ነው ጥያቄ? ያ ሁለተኛው ጥያቄ አርኬ ፎር ሪከመንድ የሚደረግበት ምን አይነት ጊዜ ነው? ሌሎች ሜቶዶች አሉ። ከነዚህ አንፃር አርኬ ፎር የምትጠቀመው ምን አይነት ጊዜ ነው የሚለውን ነው። የኔ ጥያቄዎች ሁለት ናቸው። ለሌሎቹ እንድጠይቁ ሰጣቸዋል። በፍጥነት ጥያቄ ያለው ሰው ፈተናዬ ከወጣ አላቅም እንዳትሉ። ወደ አንተ 5 ደቂቃ አለ። የቀረህን ነገር ካለም ኤክስፕሌን ለማድረግ።
Okay, the first question is why we use this
ያ ይሄ ራሱ በዚህ ስላይድ
here.
ያ
Here at this time set this at value. What's the difference? The difference is that if you when you use this star or this multiplication characters. This is for the same size of matrices, same size of matrix, but this one is for different matrix. For example, A is, as we have seen, A is what? I think 4x4 matrix, yeah, and Y is 1x4 matrix. So for this case, we use add function, add characters here. But if you use this times value, or this is used only for the same size, For example, 4x4 matrix with 4x4 matrix, just like that. And also for this heat transfer in the conduction, for heat transfer conduction in most of problems are boundary condition or blah blah. It's the different matrix here. So for multiplicating different matrix, we use this add character, but for times character, we use for the same size matrices. And also the next question, what's the next question?
RK4.
Yeah, the RK4, RK4, why we use the RK4 here? This is it. RK4 is particularly useful for systems where analytical solutions are difficult or impossible to obtain. When we can't use this analytical solutions, we use RK4 needs to obtain these solutions. And it is particularly used for the building's temperature, for the cooling and of the buildings, for chemical reaction, and for some heat, for some electrical equipment that are related with heating. So the application areas, and when we are unable to solve the equations with analytical solutions, so we use this RK4 methods. Does I get your point, or you need to add?
Yeah, more or less you try to address the question, but this is who is this? And የት ነው የማገኘው? ያንተን አድራሻ ያሬድ አይደለህም? ኢዮብ ነህ? Who is this? The presenter? መላኩ መላኩ ቆይ ኢዮብ ታገሰኝ። ለመላኩ አንድ ነጥብ ልላክለት። በአንተ አድራሻ ነው የምልክልህ ወይስ እዚህ ለግሩፑ ልላክ? በግሩፑ ልላክ።
If it is useful for the groups, you can share.
የኔን ፎርሙላ ጋር አነጻጽረው። ልክ ያለው ያው እና ምን ልልህ ፈልጌ ነው መነሻ ላይ እንትን ያልከው አኪዩሬት አይደለም። RK4 መቼ ነው የምንጠቀመው የሚለው ካፕልድ የሆኑ ሲስተሞች ሲኖሩ ነው።
The formula for the k values
RK እሱ ያ ይሄኛው የኔ ፎርሙላ ነው። ያ ይሄ በኋላ ኮምፔር ታደርገዋለህ። ያ አሁን ግን እያልኩ ያለሁት RK4 መቼ ነው የምንጠቀመው ላልኩት የመለስከው ምላሽ አኪዩሬት አይደለም። ካፕልድ የሆኑ ስንሰራ የነበረው ቴምፕሬቸር ብቸኛ ዴሪቬቲቭ በሚሆንበት ጊዜ ሰዓቴን ላቁም። ቴምፕሬቸር ብቸኛ ዴሪቬቲቭ በሚሆን ጊዜ ኦር ፍሎ ፖቴንሻል በምንሰራ ጊዜ ደግሞ የቬሎሲቲስ ብቸኛ ያ ማለት ኢንዲፔንደንትሊ ኤክስ ቬሎሲቲ ዋይ ቬሎሲቲን ካልኩሌት በምናደርግ ጊዜ you can use other methods but when temperature is coupled with velocity when density is coupled with pressure when one function is coupled in the other function እያልኩ ያለሁት ፓርሻል ዲፈረንሻል ኢኩዌሽን ሳይሆን አርኬ ፎር ኖርማል የምንጠቀመው ኦርዲነሪ ዲፈረንሻል ኢኩዌሽን ላይ ነው እንጂ ለፓርሻል ዲፈረንሻል ኢኩዌሽን አይደለም። በኦርዲነሪ ዲፈረንሻል ኢኩዌሽን ግን ኦርዲነሪ ዲፈረንሻል ኢኩዌሽን ማለት ኖርማሊ የምናውቀው ምንድነው is a function of single variable ነው። ሆኖ ሳለ ግን አንዱ ቫሪያብል ውስጥ የተሰገሰገ ሌላ ቫሪያብል በሚኖር ጊዜ አርኬ ፎር እንጠቀማለን። አርኬ ፎር እንደምታዩት ሪሶርስ ኢንተንሲቭ ነው፣ ብዙ ካልኩሌሽን ነው የሚጠይቀው። ነገር ግን ሌሎች ሜቶዶችን ከተጠቀምን አኩሬት ሪዛልት አናገኝም። ስለዚህ በዛ 3 ነው የምታገኘው። ኮድ ኳሊቲ 3 ነው የምታገኘው። ቪዥዋል 4 ነው። ኤክስፕላኔሽን 2 ነው ከ4 እያወራሁ ያለሁት ሁሉም ከ4 ነው። ፕሬዘንቴሽን ስኪል 4 ነው። ኦሪጂናሊቲ አትን ያብራራበት ልክ አይደለም። እሱን ለራስ በኋላ ታገኘዋለህ። እና አጠቃላይ 18 ከ24 ኢኳልስ ይሄ ሲካፈል ለ24 ሲባዛ 26 ከ50 የምታመጣው 38 ነው። ወደ ቀጣዩ ፕሬዘንተር